Hello, Hiltonian here. I'm about to teach you how to find true geographic solar south without a compass. This is important. Now, I'm going to put on, since it is a sunny day, I'm going to put on my glacier glasses here. Forgive my lack of eyeballs. Anyway, so if you're designing a passive solar house or a solar array, photovoltaic array, a hot water array, or if you're designing a house where you want to put solar panels on the roof, you want to be able to align it true solar south so it gets the most sun on the south side. Now you might say, well, I can just use a compass, right? Find south. Compasses will lie to you because magnetic north, the magnetic North Pole, is not in the same place as the geographic North Pole. So Santa's over here and the magnetic north is over here, a few hundred miles away. So if I was here in Vermont, which I am, and I faced true geographic north, magnetic north would be about 15 degrees to the left. If I got in my car and drove to right around the Mississippi River, magnetic north and geographic north would line up. So if I'm right along the Mississippi River, in fact, my compass would agree with the Earth as to where geographic north is. Then, if I hopped in my car and drove to Oregon, then if I looked at geographic north, magnetic north would be about 15 degrees to my right. So all told, in the continental United States, from the tip of Maine to Seattle, there's about 18 degrees either way of magnetic declination is what it's called. Aside from that, aside from the fact that magnetic north and geographic north interrelate differently depending on where you are, compasses are based on magnetism, and they're affected by steel and iron and electromagnetic fields. So if you have a power line going overhead, your compass will be off. Or a power line under your feet, buried, your compass will be off. If you're near a car or a building with big steel framework in it, your compass will be off. A compass is not reliable, but the sun is. So, solar noon, it's the first concept. When is solar noon? It's not at clock noon. It's when the sun is highest in the sky, halfway in between sunrise and sunset, on any day of the year, any place you are. Halfway between sunrise and sunset, the sun will be true solar south. Now, today is February 26th. I'm in central Vermont. So I can figure out solar noon by either going to a weather website like Weather Underground or weather.com, or picking up a local newspaper, not the New York Times, unless you live in New York, but a local newspaper, and look at the weather section, and they will probably have, they will have on the websites, but they'll probably have sunrise, sunset, length of day. They definitely do on Weather Underground. So the sun rose this morning at 6:33, and the length of the day is 11 hours. So half of that length of the day is 5 hours and 30 minutes. So if I add 5 hours and 30 minutes to 6:33, I get 12:03. So 3 minutes after noon is when solar noon is. And solar noon can, it can vary an hour or so either side of clock noon, but today it's pretty close. So if I take a pole or any vertical linear object and stand it up vertically at 12:03, it will throw a shadow directly solar north. The sun will tell me where solar north is at 12:03. So let's do that. It's 12:03 on February 26th here in central Vermont. and 12:03 in this time in this place is solar noon. So if I take this pole and set it up vertically, it will cast a shadow at 12:03 that is true solar north. So I can create a perfect geographical solar north-south line. So I'm going to do that. Put my carpenter's level on and line up the end of that shadow with that flag. Oh. There we go. So I've got that shadow, and now if I put this flag in right at the base of this pole, I have a perfect north-south line. And so if I'm designing a house or laying out a solar array, I can geometrically work off of that perfect north-south line to align the side of the building or the front edge of that solar array, perfect solar east-west. So now you have a nice perfect north-south line, but you say, hey, I want an east-west line because I need to put one face, the one face of my house east-west, or I need to put the leading edge of the solar array east-west. So how am I going to do that? Trigonometry, as we hear everybody running for the door. No, this is going to be easy trigonometry. I'm going to do it all for you. All you have to do is put a stake in the ground where your pole was, measure 10 feet north through your other flag right here, and put another stake in the ground right there. So you got a 10-foot line here. So then take a tape measure and lay out a 10-foot line close as you can east-west, just by eye. And then take another tape measure and lay out a line 14 feet 1 3/4 inches, because that is your a squared plus b squared equals c squared triangle with a right angle right here. So 10 feet this way, 14 feet 1 3/4 this way, and there we have it. A perfect east-west line to go with our north-south line. That wasn't so hard, was it? So now that you know how to make a perfect north-south line and a perfect east-west line, you can go forth and align your house properly and your solar array properly. If you have any questions about this, put them in the comments below and I will answer them for you. But now you know how to get an accurate north-south line without using a compass.